Okay. So, today we're going to be talking about how to prove angles are congruent. Our objective for today is to be able to formulate a general proof to show angles are congruent. Your homework is going to be a little different than usual. You're going to prove theorems number 3 and 4 on your own paper, and you need to turn it in to Miss Bays before fall break. So you've got the entire time, but you need to turn it in to Miss Bays before fall break. If you don't, you're going to lose credit. So that's what your homework is going to be, and the goal is. So let's move on. So first, we need to review what a theorem is. A theorem, yes, it's a proven statement of fact. Good job. So, theorem is a proven statement of fact. Whereas we had postulates. Anyone remember what postulate was? Yes. Very good. Yes. A postulate was what? Put your phone away. We don't have time for that right now. Put your phone away. Where was it? Oh yeah, you just told me. A postulate is an accepted statement of fact. Put your laptop up. Put it up. Don't. Kids. Alright, so I told you we're going to have tons and tons of theorems once we get to theorems. So today we're actually going to look at 4 theorems. The very first theorem is theorem number 1, the vertical angles theorem. Now we've dealt with vertical angles before. Vertical angles are angles that are directly across from each other, as if 2 lines are intersecting. So if 2 lines intersect, the angle's directly across from each other, like the one on top and the one on bottom when my arms intersect here. So, theorem number 1 says, if 2 angles are vertical angles, then they are equal. Pretty simple. Angles are vertical angles, they must be equal. Looking at an image here, we've got some sets of vertical angles. We have angle 1, 2, 3, and 4. We know angle 1 and angle 3 are vertical angles because they are directly across from each other. We know angle 2 and angle 4 are vertical angles because they are directly across from each other. Since they are vertical angles, by the vertical angles theorem, they must be equal. So angle 1 is equal to angle 3, angle 2 is equal to angle 4. Now, this section is proving angles are congruent. So we need to prove that these angles are, in fact, congruent, or they are equal. Because remember, congruent and equal are basically the same thing. We're going to focus on just showing equal for now, because that's what you'll deal with mostly on math space. But eventually, when I get back from China, we will look at showing congruent instead of just equal. So, proof. We are given angle 1 and angle 3 are vertical angles. So we are going to show that they are equal. Notice, we're going to follow our conditional statement that is given for the theorem. If 2 angles are vertical angles, then they are equal. Therefore, we need to be given 2 angles are vertical angles. We are given angle 1 and angle 3 are vertical angles. We prove our conclusion. They are equal. We are going to prove that angle 1 and angle 3 are equal. This is how we work through every proof. And in order to do that, we are going to have to use our 2 columns. Our 2-column proof, where we have statements and reasons. So that's what we're going to start with. Statements and reasons. Now, we've talked about this a little bit before with our justification, but what is always the very first thing in every single proof? the given statement. So we always put our given statement first. We are given angle 1 and angle 3 are vertical angles. So that's what we're going to state first, and we're going to say it is given. Angle 1 and angle 3 are vertical angles. Now right here, you'll notice I'll start using this more, otherwise we're going to be putting up a lot of words. I'm going to start using abbreviations and symbols for some words. Using the angle symbol for the word angles. And if I'm talking about plural, I put a little s at the end. So angle 1 and angle 3 are vertical angles. Reason? It's given. So, angle 1 and angle 3 are vertical angles. From there, we've got to think our way through this. We have to think, okay, let's look at this picture. What do we already know? What definitions or anything else do we already know? Or maybe we have to take a step back a little bit and look at our postulates. Remember we had 7 or 8 postulates before the first test? Well, we're going to have to take a step back and look at some of those sometimes to help us out. Because our reasons can be anything from definitions, to properties of equality and congruence, to postulates, to theorems we have previously learned. Any of those. You can't use a theorem that comes after the theorem we are learning, and you cannot use a theorem that is the theorem that we're trying to prove. If you're trying to prove a theorem, you cannot use that theorem to prove it. But you can use any before. However, since this is our very first theorem, we can't use any other theorem. So we just have our postulates and our definitions and our properties of equality and congruence to use. Now what we notice is we've got 2 lines that are intersecting. These lines form multiple angles. We can see angle 1 and angle 2 form a straight line. Taking it back a minute to postulate number 7. So if you look up in your notes, postulate number 7, you will find that that is the linear pair postulate. The linear pair postulate states that if 2 angles form a linear pair, or they form a straight line, then they are supplementary. So we can use that to our advantage in proving that angle 1 is equal to angle 3. First, let's say that angle 1 and angle 2 are supplementary by the linear pair postulate. Angle 1 and angle 2 are supplementary by the linear pair postulate. Now again, I'm using abbreviations. SUPP, period, for supplementary. POST, period, for postulate. Number 7, I put there to reference which postulate number that was that we have talked about. So angle 1 and angle 2 are supplementary by the linear pair postulate. Now, looking back up, we need to get to where we're saying angle 1 is equal to angle 3. So far, we've got that angle 1 and angle 2 are linear pairs. What other angles might be linear pairs? Yes, very good. Angle 2 and angle 3 are also linear pairs. Therefore, we can say that angle 2 and angle 3 are supplementary by the linear pair postulate. So we have angle 1 and angle 2 are supplementary. We have angle 2 and angle 3 are supplementary. We are using vocabulary terms that we know in our statements. So when we use these terms we know in our statements, we can and we should try to see if we can use their definitions to help us figure out other statements. So what does it mean to be supplementary? Yes, ma'am. No, not 90 degrees. They don't add up to equal 90 degrees. Those are complementary angles, which we'll talk about those in a little bit. Complementary angles add up to equal 90 degrees. What are supplementary angles? Yes, sir. Yes, supplementary angles add up to equal 180 degrees. So if we know angle 1 and angle 2 are supplementary, what will angle 1 plus angle 2 equal? Yes, 180 degrees. And what's going to be the reason we use? Remember, we have vocabulary terms here. So we need to use the what of those vocabulary terms? Yes, the definition. Good job. So we know angle 1 plus angle 2 equals 180 by the definition of supplementary. Again, abbreviation, DEF for definition, and there's that SUPP again for supplementary. So what's next? We've got angle 1 plus angle 2 is 180. Yes, angle 2 and angle 3 will add together and equal 180 as well for the same exact reason. So angle 2 plus angle 3 equals 180 by the definition of supplementary. So now, we've been using a lot of stuff from the past here, from quite some time ago. But now we got to think what we just learned recently before this test that we had. We have angle 1 plus angle 2 equals 180. We have angle 2 plus angle 3 equals 180. What can we do with that? What is there to be done? Okay, so what do they both share? Yes, they both have angle 2 in it. Good job. What else do they share? Yes, they both have 180. Notice the 180 is by itself in both cases. So what do you think we can do with these two statements? Yes, very good, very good. Because the 180 is by itself, but it's equal to both of those, we know that we can take angle 1 plus angle 2 and set it equal to angle 2 plus angle 3. So angle 1 plus angle 2 equals angle 2 plus angle 3 because we're cutting through the middleman. We're cutting through that 180 and skipping right over it. Now what property of equality, and we know it's going to be of equality because it's an equal sign, what property of equality allows us to do this? No, it's not the symmetric property. You're close. Not the symmetric property. Yes, it's the transitive property. You're on fire today. Good job. So the transitive property of equality allows us to say angle 1 plus angle 2 is equal to angle 2 plus angle 3. So angle 1 plus angle 2 equals angle 2 plus angle 3 by the transitive property of equality. And again, another abbreviation, property we shorten to prop, P-R-O-P. You don't have to, you can spell out the entire word, but sometimes it gets tiring spelling out the entire word. So transitive prop of equality, we recognize. What is the result we are trying to get to? Yes, we want to say that angle 1 and angle 3 are equal. We are at angle 1 plus angle 2 equals angle 2 plus angle 3. We want to be able to say angle 1 is equal to angle 3. We've got this angle 2 on both sides of the equation. So what can we do to get rid of angle 2? Close, really close. Yes, ma'am? Yes! We can subtract angle 2 from both sides, because see here we're adding angle 2, and there's no sign in front of angle 2 here, so we assume it's positive. So if we subtract angle 2 from both sides, we are left with angle 1 equals angle 3, and if we're subtracting, what property is that? Yeah, it's the subtraction property. Good job! So we know that angle 1 equals angle 3 using the subtraction property. Therefore, we have proven angle 1 is equal to angle 3. Now, yes, it was quite a few steps, but it's because we had 2 that are linear pair postulates, and 2 that are definitions of supplementary, and then we just had a couple more steps to go. The hardest steps are figuring out what 2 and 3 were supposed to be. Because we had to use our brains, we had to use our knowledge and our intuition to figure out what goes there. We had to use deductive reasoning. But once you figure that out, it became pretty smooth after that. So, this is a video. So if you're confused about something, pause it, look over it, rewind it, and keep watching until you get it. However, this is a video, so since you can do that, I'm going to move on. So now we're going to look at theorem number 2. So we just went over theorem number 1, the vertical angles theorem. Now we're going to theorem number 2, which is what we call the congruent supplements theorem. The congruent supplements theorem states, if 2 angles are supplements of the same angle, then the 2 angles are equal. Now you might be thinking, what are supplements again? So I'm going to ask that to you. What are supplements? What are supplements? Yes! It means 2 angles that are supplementary. Okay, so what does supplementary mean? Yeah, that 2 angles add up to equal 180 degrees. So if 2 angles add up to equal 180 degrees, and 2 angles are equal to 2 angles with a third angle, each add to equal 180, then we know these 2 angles here must be equal. A little confusing, I understand. So let's look at a picture. So we have 3 angles here. If 2 angles with a third angle each add up to equal 180, then they are supplements and these guys are equal. So, if angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 must equal angle 2. So again, I think with pictures it's easier to explain. If angle 1 and angle 3 are supplementary, if they add up to equal 180 degrees, and angle 2 and that same angle number 3 are supplementary, meaning they add up to equal 180 degrees, then angle 1 must equal angle 2. But again, we have to prove this. So proof. Our given, what we're going to be given, is again the hypothesis of our conditional statement. Angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. So that's what our given is going to be. Angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. So again, we're proving. So we got to make the 2-column proof. We have to have our statements, we have to have our reasons. So statements and reasons. What is the first step? Yes! It's the given. So we restate our given. Angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, and the reason is given. Now again, I'm using my abbreviations here. SUPP for supplementary. So angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. And again, it's given. Then this is really similar from here on to our last proof. We've got that word supplementary. It's a vocab word. So what does supplementary mean? Yeah, that it equals 180. So angle 1 and angle 3 are going to add up to equal 180 by the definition of supplementary angles. Same thing for angle 2 and angle 3. Angle 2 plus angle 3 will equal 180 by the definition of supplementary angles. Does this look familiar? It should. We just did something like it. Angle 1 plus angle 3 equals 180. Angle 2 plus angle 3 equals 180. What do they have in common? Yes, they've got the angle 3's. Good. What else? Yes, back there. Right, the 180s. The 180s are in common. And again, the 180s are by themselves. So, what can we do with this? Yes! We're going to set them angle 1 plus angle 3 equal to angle 2 plus angle 3. Good job. You are all doing fantastic today, by the way. So keep up the good work. Now, what property of equality lets us do that? We just went over this one. Yeah, the transitive property. So, angle 1 plus angle 3 equals angle 2 plus angle 3 by the transitive property of equality. I got a little tired. I didn't like writing the word equality anymore, so I just put an equal sign. Transitive property of equality. So, just one more step, same step as last time. Yes, sir. Yes, subtraction. Where are we going to subtract? The thing we have in common, which is angle 3. So subtract angle 3 from both, and we get that angle 1 equals angle 2 by the subtraction property. Good job. So angle 1 equals angle 2 by the subtraction property. Any questions? Oh, this is a video. So as a reminder, if you are confused, please pause, rewind, watch it again. Still confused? Pause, rewind, watch it again. Still confused? Use those MacBooks that you have. Instead of getting on Facebook or playing games, Google it. Or look on MathSpace. So get off the games. Get off Facebook. Do something. Make sure you understand. And since this is a video, I shall move on. So now, theorem number 3, the congruent complements theorem. Now, I don't know if I didn't pay attention if I did this last time or not, but THM, that's an abbreviation that is often used for the word theorem, because we get tired of writing the word theorem, so we put THM. If you see me put THM, that just means theorem. So the congruent complements theorem. Very, very, very similar to the congruent supplements theorem. If two angles are complements of the same angle, then the two angles are congruent. The only difference in words here, supplements became complements. Pictures. We have angle 3, angle 1, and angle 2. These pictures show us that if angle 1 and angle 3 are complements, and angle 3 and angle 2 are complements, then angle 1 is equal to angle 2. Very, very similar to the congruent supplements theorem. You just have to know what it means to be a complement, which we went over just a little bit ago. Again, it's a video. If you don't remember, rewind. This theorem, the you will prove on a separate piece of paper, don't put it in your notes, separate piece of paper, you are going to prove this using a 2-column proof and turn it in. I highly suggest you look back at theorem number 2 to help you with this. Except now you're using complements instead of supplements. So you're going to prove this and turn it into Miss Bayes so that whenever I get back from China, I'll see that you turned it in and I can look over it. Okay? Okay. One more theorem for today, and then we're done. Theorem number 4, the right angles theorem. This theorem states, if two angles are right angles, then they are equal. If two angles are right angles, then they are equal. So we look at two angles that are right angles. Here's a right angle, there's a right angle. Angle 1, angle 2. We're saying they're equal. If angle 1 and angle 2 are right angles, then angle 1 equals angle 2. Makes sense? Again, you will prove this and turn it into Miss Bayes. When you get started on this proof, you need to remember what the definition of right angles are. What does it mean to be a right angle? What is the measurement of a right angle? You are going to use that in your proof. So once you know what the measurement of a right angle is, then it's going to be really, really simple to say that angle 1 is equal to angle 2. This proof is not complicated, so don't make it complicated. Alright, so that is it for today. If you have any questions, rewind the video, watch it again, watch it a third time, watch it a fourth time. Maybe Miss Bayes has some guidance, I'm really not sure. Google it, look it up on MathSpace, whatever it takes. But remember, you need to prove theorem number 4 here, the right angles theorem, and theorem number 3, the congruent complements theorem. You need to prove those on a separate piece of paper. Now, they can be proven on the same piece of paper. I would actually prefer that. Put them on the same piece of paper. You can have one on one side, one on the other, or both of them on the same side, because you should be able to fit both on the same side. And you are going to turn that in before you leave for break. Okay? Alright. Until the next day that you see a video of me, adios.